This is an example of how you can graph an exponential. Note it's an exponential growth because you're raising something to a power, in this case the power of x, and what you're raising is more than 1. So you keep multiplying something bigger than 1 by an increasing power. What you'll find is that the graph very quickly gets very large. So let's take a look at how that actually behaves. The way to graph anything we're not too familiar with is to pick some x values and see what the corresponding y value is. Now, if I were to plug in 0 to the equation here, in this case for x, I would get basically 2 times 1.5 to the power of 0. So anything to the 0 power, we recall, is simply 1. So this would simply be 2 times 1, or 2. When x is equal to 0, therefore y is going to be equal to 2 in this case. And we can also see some additional cases. Now I'm going to plug in 1. So let's see what happens when I put 1 into this equation. That's going to give me 2 times 1 plus 0.5. So it's 1 plus 0.5, or 1.5 to the power of 1. So that case, it's going to be 2 times 1.5. 2 times 1.5 is going to be 3. 1.5 to the first power is simply 1.5. Anything raised to the power of 1 is just itself. So this is going to be equal to 3. Therefore, when x is 1, y is equal to 3. Let me graph our first 2 points. At 0, I have 2. At 1, I have 3. Okay, so far not doing too much. Let's take a look now at 2. What happens when I graph 2? And this is where it's going to start taking off a little bit. 1.5 squared is 1.5 times 1.5. Or 2.25. If I do 2 times 2.25, that's going to equal to 4.5, or 4.5. So it's the pace of which this is expanding, starting to pick up a little bit. That's going to be 2 and 3, 4.5, right about here. If I go just one more, I think we'll really get a sense of how this thing takes off. I'm going to plug in 3, and that's going to give me 2 to the 1.5 to the third power. Okay, that's 1.5. The third power is 1.5 times 1.5 times 1.5, and that's going to be equal to 4.5 times 1.5, so that's going to be equal to 6.75. So now that I'm at 3, I'm going to be up to 6.75. And so at 3, 1, 2, 3, I'm at 4.5, 5, 6, 7.5, and we can start to get the idea of how this graph is really going to take off. If I were to go in the opposite direction, which is why I left this space open up here, let's take a quick look at -1. -1, if I were to plug in -1 into here, that would be 2 times 1.5 to the power of -1. -1 is equal to, raise something to the -1 power is 1. So when you evaluate 1.5 to the -1 power, that's the same thing as doing 1 over that thing. So 1 over 1.5. And 1 over 1.5 is actually going to be equal to 2/3. So this is going to evaluate to 2 times 2/3, which is 4/3, or 1 1/3. Therefore, at -1, the value here is 1 1/3. And because of this effect, because you're evaluating it to a negative power, it's going to increasingly go down, and it's going to get very close to 0 without actually ever hitting it. So here, my 1 1/3, I know it's going to group together, but it'd be about there. Overall, the shape of the graph, therefore, is going to look something like this, where you can see it just shoots up very quickly at the end. So that's what you can expect from an exponential growth function. That's it. Thank you.